Hello, this is an unscripted kind of disaster movie recording. It's the end of August, near to the beginning of September 2023. And as someone who's worked as in many different IT roles, but one of the most enjoyable was enterprise storage consultant. And I can tell you that if you're a storage consultant, then losing somebody else's data is unforgivable, but also I think at the same level, losing your own data would be perhaps a greater sin. So imagine my surprise when I was pottering around on the cron tabs of my Apple computer, where I've set up some regular backups, and I was amazed to find that the one of our WordPress backups is not working. And it turns out that my shell scripting isn't up to scratch anymore, and I'd missed an exclamation point. So instead of checking whether a directory did exist, it was checking the directory did not exist. And so my backups were failing. I haven't been working since about March. And then I started digging deeper, and I researched the fact that now we are a mixed Apple and Intel household. I really do need to get my act together and sort out the data flows and the kitty flows. Baby, no. No one's going to be watching this now. You're the star of the show. We all know that. Right, I should continue. Since I'm now living in a mixed environment in the sense that I have an Apple computer, which is the primary owner of certain data, and I still have a large Intel server, which is the owner of other data. So let's let out the princess. Come on, princess, then you're going to go and listen. We want you to stay. Right. Okay. Yeah. I hope I'm not losing viewers at a greater rate than I've lost the princess. So on this diagram, I'm attempting to show the revised plan. And I don't know to how many people this will apply, but I think it's a good data flow diagram. And I want you all to look very carefully. So here we have it. We have the Apple computer on the left here. And this Apple computer has the same data layout as the old Windows server, but now, although there's the more or less identical data is in two different places, since I created the Apple computer, there's obviously been it's now out of sync. So to give you an exact example, virtual machines. Okay, well, since Apple very poorly supports Intel virtual machines, in fact, you can't really have virtual machines under Apple per se. You can go through QEMU and try, but it's a bit half-hearted. And Apple, in its new Apple Silicon guise, can help you virtualize other Apple Silicon products. But if you want to run Windows XP with any kind of dexterity, you're out of luck. So in this diagram on the right-hand side, this Intel machine is still the owner of all the virtualization machines. And since about 2016, so several years now, I only had one actual physical system. I got rid of all my other physical systems, and all the virtualization was going on here, whether it was OS2 or Windows XP, or even Chromemco 8 and 16-bit systems were virtualized on this platform. So in the new brave order, where I'm now having an Apple computer as a daily workstation and the Intel server as not just an add-on, but it's not so prominent anymore, I would still say that the ownership of the virtual machines is on the Windows side. And conversely, for example, all photographs are living on the Apple side. So these arrows are indicating the source to target relationship. And so, for example, in the data directory, I basically want to have data coming in from laptops and from smartphones, and that would go into the Photos directory, for example. And periodically, I want a process or a program, which will be rsync, by the way, to take the information here and compare it for what's on the target, and then sync the difference. In fact, you can probably see I've got one running in the background here. It's just, whoa, what a palaver it is. Can we see? Can you see that? It's just, oh my goodness me. So on this, I want to explain the diagram. I think it might be useful. So let's look at it in more detail. So the left-hand side is the Apple, the right-hand side is the Intel server. The arrows indicate the direction of data flow. So we've got WordPress systems. They are on a pull. They're on a pull going into the Apple. We've got the documentation server. That's on a pull going into the Apple. So the Apple is the principal backup for the documentation server. And the same with the smart home and the Raspberry Pi farm. And if you recall, our smart home is populated by over 100 little computers. They are all backed up. And we also have at least 10 Raspberry Pis doing all sorts of functions, like it could be DNS blocking, it could be a firewall. I have one which is physically emulating an old 1980s computer. All those Raspberry Pis need backing up, and they're all pulled backups onto this directory here. Okay. In the corner here, we have a bunch of Apple computers, and rather like Steve Jobs said in many decades ago, before the infamous transition from PowerPC to Intel, he said, "Oh, we've had an Intel port of OS X, as it then was. Oh, it's been running for decades in the basement. We've never told anyone about it." Well, for decades, although I've been an Intel person, I've had a basement with Apple computers in it, just in case they got any good. And right now, they are good. And the segue is that effectively, Apple computers now with Apple Silicon are such a powerful platform that it's hard to ignore. And I can't deny the fact that Intel hasn't kept up. Microsoft has had farcical attempts to produce ARM platforms to replicate what Apple has done, and Microsoft's transition to ARM is basically, I wouldn't say it's dead, but you know, they're not trying too hard, are they? Let's face it. I'm back again. So there's been about a 12-hour delay in the second part of this video due to the fact that the Apple Mac Mini keeps crashing. To be fair, it is a third-party binary. But why rsync, which is not a kernel mode program, can possibly crash the computer, who knows? Anyway, I'm continuing to complete this data flow diagram, which is that all of these machines here are on pulls, and they deposit their backup information into a directory called backup. And then, as I've said before, this is the left-hand side, which is the Apple. This is the right-hand side, which is the Intel. They've each got their domains where they are authoritative. And in this case, there should be a routine that backs up using rsync. This is in the process to be made between the Apple which is the master, and the Intel server, which is the slave, if you like. But just to explain the other point of this diagram, this is my bank of older Macintoshes that aren't really backed up. They might have an ad hoc backup to a Time Machine external drive, but they don't sort of form part of our full-blown infrastructure. They're sort of all by themselves in the basement. And these are local machines because we subscribe to Amazon Prime. We've got unlimited photo storage, so the Mac computer runs the Amazon Photos app, which you can tell it to take one or more directories, and it uploads those directories to the cloud free of charge. You have a limited photo storage. So I literally have hundreds of thousands of photos up here because I take a lot of photos, and it's a lifetime's work. In fact, multiple lifetimes of different people are uploaded in our family to this account. Meanwhile, at the operating system level, the Mac backs up to a time machine. It's not an Apple time machine because that would be a product that they stopped selling about a decade ago or some long period ago. It is, of course, in this case, it was a QNAP NAS. Well, that seemed to be more problematic than it was worth. So it's just an external disk cabinet. And the Windows Server has within its chassis, it's got a separate NVMe drive. And Windows Server has, as part of its standard software suite, backup. So every 24 hours and on catch-up, this Windows Server will make a backup of its entire operating system to that other NVMe drive. And should the system go down, rather like with, should the system go down, you can restore the boot drive. And finally, these are on-site sort of situations. We have a room, not in the same room, but in the same geography. As in, if the house burnt down, we might be safe. A NAS which is backed up to, and that receives the backup of all of these bits of information. And since, for example, the Mac is secondary on virtual, but since it's doing a pull from its primary, which is the Intel server, that should get to the NAS and be up to date. And, as if that wasn't enough, periodically an off-site physical disk is made. Oh, I have one with a prop. Let me get a prop, shall I? Hang on. It's not a prop, it's an actual. It's a disk waiting to go. Packed up and everything. Yeah. It's a 12 terabyte disk. It's packed up, ready. It's in the shockproof casing, and that's ready to be transported off-site. So that's an example of a disk to go. By the way, it's suitably encrypted in case you want to break it and try and decrypt the information, so you'll never get into it. And lastly, but not least, the NAS has a cloud account, and using Amazon Bucket technology, there's a link between the NAS and the cloud. So that's the entire data flow for our household. And I hope that explains the data flows. And the key thing is that it all started off with this missing backup from for one of our satellite systems here. That's been corrected, and the next challenge is to make a script, an rsync script. And I found out that the rsync doesn't crash if it's lightly used. In other words, if it's synchronizing, let's say, tens of gigabytes, it seems to stay up. If it's trying to synchronize hundreds or thousands of gigabytes, it falls over. So once this has been set up, I think it'll be good enough and it'll stay up. It'll be in a cron tab, and the script will run every 12 hours or so. Okay, Dari, now you know everything. That's it for now.